Hi, my name is Derek Laddick. I'm with the Institute of Cyber Science, and I'm here today to talk about our advanced cyber infrastructure and our Open Queue, to give you an introduction to the Open Queue. We'll talk about a number of things as we go through this presentation. For those of you who are watching this presentation is available online. You can find it under our support page at ics.psu.edu under our advanced cyber infrastructure. So if you want to follow along there, in case you can't see something in the background behind me, you can follow along in the slides there. Those slides also contain all the links or any links that you would need to get access to accounts or anything like that as we go through this. So I'm going to talk about it. You'll hear the term ICS and ACI or ICS-ACI put together. ICS is just the Institute of Cyber Science, which is one of 5 institutes here at Penn State. ACI is the name for our high performance computing system, our advanced cyber infrastructure. So ACI stands for Advanced Cyber Infrastructure. Okay, so the agenda for what we're going to talk about today. I'm going to give you a quick overview of what ICS-ACI is and what that means. We're going to talk about our Open Queue. We'll talk about a number of different things: user accounts, two-factor authentication, logging into the system, storing and transferring data, accessing our software and software that we have available, our central stack, submitting a job, some guidelines for utilizing the Open Queue, and last, certainly not least, and most important, is how to get support when you need support. Okay, so I'll give you a quick overview of ICS-ACI, our system architecture and system specifications, talk a little bit about the different core types. The system itself really consists of 4 parts, which is the compute, the storage, the network, basically, and then the interconnectivity. So the picture you see in the background there, that's the picture of our advanced cyber infrastructure. It's located in our data center, basically. That's the racks of equipment that we have available. I'll talk a little bit about the breakdown of each one of those. As you can see, it's a very new facility. The facility was just stood up in the last year and a half or so, and obviously that's where all of our equipment is housed today. So the computing system itself, okay, I talked about the 4 different parts that it contains. Everybody who comes into the system comes in via the login nodes, okay? So just like any other system that you have, you're going to log into those login nodes, and that'll determine where you go after that. You have 2 different types of systems. You have an interactive and a batch system. Okay, those have some different attributes. Our interactive system is for interactive jobs, visualization, those type of things, small jobs. Our batch system is for larger jobs, parallel jobs. The batch system contains a number of different types of cores. We have basic memory cores, standard memory cores, high memory cores. GPUs we don't have quite available today as of this taping. Okay, this is on November 1st, so we don't have that available as of today. We expect the GPUs cores to be available in the spring of 18 sometime. So you see there, ACI-b stands for our batch system, Advanced Cyber Infrastructure Batch. ACI-I stands for our interactive system, okay? And you can also see on there, we've got a high-speed network that connects everything together. We have both active and archive storage pools, okay, which I'll talk a little bit about later on. And as you can see, encompassing the compute cores is our centralized software stack. That stack is available on both ACI-I and ACI-b, so you can access that from either one. Batch systems are just that. They're configured to execute jobs submitted to a queue, okay? There's an open allocation. There are specific allocations for some PIs that have chosen to purchase an allocation. Those are for batch processing jobs. Interactive systems, they utilize a common GUI, okay? And I'll talk about that common GUI and some instructions and ways that you can access that a little bit later on. So the system specifications. So ACI is Advanced Cyber Infrastructure. I talked about that before. You might hear the term utilized: high performance computing systems, supercomputer, those type of things. But ACI is our Advanced Cyber Infrastructure. That's what we call our system here. It is nothing more than on-site hardware and software designed to support PSU researchers, okay? We've got a number of different types of cores to allow for different jobs. Total in the whole system, we have a little bit over 23,000 cores today, okay? You can see the breakout in there in the presentation of what those entail. There's roughly 1,000 high memory cores for high memory jobs. The specific specifications you need to know about that is 1 terabyte of RAM, 40 cores per node for the high memory cores. There's around 10,000 standard memory cores, okay? So we do have two different types of processors for these. There's Ivy Bridge and Haswell. So if your code is optimized to run on one or versus the other, right? That is something you can submit to the queues to indicate whether you want Ivy Bridge or Haswell. Specifics for those, obviously 256 gig of RAM per node and 20 cores per node for both of those. The new Haswell has actually 24 cores per node. 4 of them we reserve for our Open Queue and overhead, so their utilization is 20 cores available per node. We have roughly 7,000 basic memory cores, okay? I forgot to mention this, high memory and standard memory both utilize InfiniBand, okay? So that's the high-speed fabric. They both utilize InfiniBand. Basic memory cores do not have InfiniBand capability, okay? But basic memory cores, 128 gig of RAM, 20 cores per node available. Again, we keep the 4 cores for overhead or Open Queue. And then we have about a little over 5,300 legacy cores that will be combining with the ACI infrastructure. Part of the reason for this presentation is we had the decommissioning plan that was presented and approved last year. We've been going through that process this year, and by the end of the year all the legacy systems will be shut down. So, but some of those legacy cores are still usable, and so those cores will be assimilated into the ACI infrastructure and utilized in that as well then. Storage. So we have a number of different storage options. I say a number, we really have archive and active storage, so 2 different storage options. You can take a look there. We have a large storage pool. We have a little over 7 petabytes of active storage. I'll talk more about the different groups of storage, homework group, Scratch, a little bit later on. But you can see the breakdown of where that little bit over 7 petabytes comes into play. We also have a total of about 12 petabytes of archive storage. Archive, or you may hear the term nearline, is storage that's stored off to the side. It's something that doesn't need to be accessed consistently or quickly. Also, you cannot run any jobs against the archive storage. So the archive storage is not available from the batch system or the interactive system. If you want to utilize that storage or any files from there, you would have to move them over to one of your other directories to be able to utilize that. So I want to talk about using the Open Queue or utilizing the Open Queue. Anyone with a Penn State account, an active Penn State account, can get access to our system. They can get an account on the system to be able to try to run jobs. You will need a sponsor or principal investigator, primary investigator. You might see the term PI. When I say PI, that's what I refer to. You can use your advisor if you don't have a PI per se, if you're a student and you want to try and get on. But as long as you have a valid user ID, students, faculty members, staff members, also, you could, Friends of Penn State, if you have a Friends of Penn State account, or if you need an account, if you have external collaborators, they can utilize they have what we call a SLIM account, so they can get access via a SLIM account. That process does take a week or 2 to get all the accounts set up, so if you need that, I highly suggest you apply for that earlier rather than later. Okay, so how do I sign up for an account though? So everyone is required to have an account. Even if you had an account on the legacy system, you still have to sign up for an account on ACI, okay? The link is on here, okay, accounts.aci.ics.psu.edu, okay, you can sign up there. You will need to indicate your principal investigator or primary investigator in there, okay? So you'll need to put them in. If you are a faculty member, you do not need to have a PI, okay? You can sign up for your own account. It will get you access to the open allocation at that point. Out-of-state users from Penn State, collaborators, you must, if you don't have a Penn State PSU ID, you must first apply for one. You can apply for a Slim account currently on our website. That'll get you access to a Slim account. And then you would also need to sign up for an ACI account. So if you're a collaborator, first step, get a Slim account, get a PSU ID. Second step, sign up for an ACI account. And as you can see, we've developed a number of short videos. There's a link to one in here, basically, that kicks off our video about how to sign up for an account, walks you through that process. Two-factor authentication. So for anybody at Penn State, this is obviously something you're familiar with now. If you're coming in as an external collaborator, you may or may not have this at your location, university, wherever you may be. But Penn State requires two-factor authentication for everything for security purposes today. We utilize two-factor for logging into any of the systems. So you have to have a two-factor account. So 2fa.psu.edu, you can sign up for a two-factor account. The Institute of Cyber Science does not handle two-factor, okay, so we don't have the ability to make any changes. We can't grant you an account. We can't do anything like that. That's handled by a totally separate department, the Identity Services Department. You would have to contact them to get an account. For Duo, a couple things I'll mention for 2FA before I forget and while I'm on it. You can sign up for an account, obviously. There are multiple methods. You can list multiple methods to sign or to log on via two-factor. I highly encourage you to have more than one thing. Your cell phone, I'm pointing to mine by the way because it's sitting on the desk. Your cell phone, there's apps for Android and iOS, okay? So there's apps for those. You can download the Duo app, look up the Duo app, download the Duo app. It's great. I use it 98% of the time, but I also have my office phone listed as well as my tablet at home. So in case my phone dies or I don't have it with me for whatever reason, I can utilize that. Last but not least, they also do have tokens, Duo tokens. There is a charge for those tokens, but you can purchase those at the software store. You need to ensure that you purchase the Duo token though, and not necessarily, there are different tokens. I know faculty members have a different token for their grading system, but the Duo token is the one that you need. I think the cost last I checked was around $20 or so. Okay. So I talked a little bit about the interactive and batch systems earlier on. We're going to talk about logging into the interactive system. So you can log into ACI-i, but you need to utilize a common GUI to do it. And that common GUI that we use today is Exceed on Demand. There's not only a link on the presentation for utilizing Exceed on Demand, but there are also instructions. If you go to that link, there are also instructions, step-by-step instructions on download, setup, configuration, and then that'll allow you to log on to ACI-i. ACI-i is an interactive system, so when you utilize Exceed on Demand, it'll bring it up, it'll look like a new desktop on your computer, and you can utilize it for that. If you want to utilize ACI-i for visualization purposes, that would be where you would go. You would go to ACI-i. That would allow you to utilize the visualization tools that are available, for example, in MATLAB or something like that. Logging into ICS-ACI from Windows. There's probably a number of you out there that are Windows users, never used Linux or Unix, okay? It can be a little intimidating at first, but like anything else, once you actually try it, it's not as bad as it seems initially. But for Windows, you need to download a third-party application. I've used PuTTY, okay? What you see here, there's a link for downloading PuTTY. Also, there are instructions on there for setting up and configuring PuTTY. On the flip side of that, there's also another program called MOBA Xterm. I've utilized that one as well. It's got some features I like that I just found out about it for some reason a couple months ago because I don't run a lot of jobs on the system, but it's got some features that I like, so I downloaded that and utilized that more now than I did PuTTY. But please try them both out. If you have questions or issues, I'll talk a little bit later on about our iAsk Center. You can talk to our iAsk Center and they'll be able to help you out. What if you're using a Linux machine or you're using Mac, okay, you're not using a Windows machine. Mac users, there's actually a terminal session, so there's a terminal application on your machine. You can open that terminal application and you would SSH in, okay. please include that $Y. That enables X11 forwarding for your entire session. Okay, if you're logging in from Linux or Unix, right, you can utilize the SSH command or your SSH editor and log in that way. Okay, storage. So each user that signs up for an account basically gets a home, work, and Scratch directory. Okay, so you get three different directories when you sign up. The information's on the slide here. Couple things to note: home 10 gigabytes, maximum 500,000 files. It is private, cannot be shared with anyone. Okay, it is backed up and recoverable. Okay, work directory 128 gigabytes, maximum of 1 million files. Okay. It is also shared, or it is shareable, okay? So you can share that with other members of your group or other members that are on ACI. It is also backed up and recoverable. Scratch, everybody gets access to a Scratch directory. We like to think of that as your working directory. So as you're doing your runs, you're actively storing data off onto your Scratch directory. Once you have the results that you want, you take them off of that Scratch directory and move them over. Couple caveats to Scratch, okay? Number one, Scratch is 1 million files, maximum 1 million files, no more, okay? It is not backed up. I cannot stress that enough. It is not backed up. So if something were to happen to Scratch today, everybody's data would be gone off of Scratch. Okay, so please make sure that any critical data that you have to your research, you store off in a work directory or some other location. I'll talk about group directories here in a second. That's another option. But please make sure that any data that you have that's critical is stored off on there. Scratch is not backed up, not recoverable. The other thing to note on Scratch, you see the big long disclaimer that we have at the bottom of the slide there. That big long disclaimer just says we delete files older than 30 days on Scratch, okay? You know, we don't look at it. The Provost has made a significant investment in the storage facilities that we have, and so we don't look at Scratch as somewhere where people should be storing terabytes of data long term. There are other options to do that. But we do recommend that you get any files older than 30 days off of there that you would need. We do run scripts every day. Basically, they go in and clean up the data that delete any files older than 30 days. If you're utilizing touch scripts, that is a violation of the policies, okay? If you don't know what touch scripts are, don't worry about it. You're not utilizing them. But if you're utilizing touch scripts, that's something that we have the ability to check into. That's a violation of our policies. Your account can be locked at that point, okay? So don't do it, please. We don't like to come down on people, and they don't like it when we do it either. So utilize Scratch for what it's for, your working directories. Move the data off of it once you've got what you need. We also have group directories, and group directories come in two different forms: active and archive storage, or nearline storage. You might hear archive and nearline intermixed together. Active storage is just that. It's active storage. It's storage files that you can utilize. You can pull them back and forth. You can open them up. You can run the data against your codes, basically. You don't need to do anything else with that. Archive storage, nearline storage is kind of stored off to the side. We call that cold storage. It's used for large data sets. Obviously, if you have a lot of data, I think we have folks that have about a petabyte right now in archive. It's also utilized for data for maybe grants, for example. So if you've got a grant, you need to store the data off for 3, 5, 7 years after the grant ends. You can store that in archive. It's got about a 5x, just about a 5x savings over active storage. They're both really attractive price points. Both active and archive are backed up and recoverable. You would need a PI to have either of those. So group storage, either active or archive, a PI would need to sign up with us. And we would create something called a service level agreement. You might hear the term SLA. We would create those with them for the amount of storage you need. Both of those are in 5 terabyte blocks, okay, so you have to purchase in 5 terabyte blocks. Storing your output, okay, so obviously you've got a number of different ways that you can store your output. I talked a little bit about these before. I'm not going to go into a lot of detail. The path names are on this slide, okay, for your home, work, Scratch directories. If you have a group directory, obviously that group directory would be under your PI's name. That pool name indicates what your PI, and that information will be given to your PI, okay? So your PI would have where the pool name was if he signed up for a group account, okay? Just a note, right? Our storage is in security compliance with the Office of Information Security here at Penn State. We've done a lot of work. We had an audit about a year and a half ago. We've done a lot of work to ensure that's the case. There's a note there on the right. If you have special needs, so if you have restricted data types, okay, dbGaP, NIST, those type of things, contact us. We can support those. We have a plan in place right now to be NIST certified by the end of 2017. So starting January 1st, 2018, we will be NIST certified, 800-171, so we can handle NIST type data as well. So export controlled, any of those types of data, contact us. Those are kind of special circumstances. We have to go through a process with the Office of Information Security, create a security plan, a technology management plan, just make sure everybody signs off. But it's in your best interest because it allows you to be able to securely store the data and not have to worry about it at that point. Storing your output on archive, okay. Archive data is only available through the data manager nodes. So from your active data, you can access those from ACI or interactive environment, or ACI-b or batch environment, or you can access this through our data manager nodes. If you just want to move data back and forth, you can log into the data manager nodes and access it via there. Okay, the data manager node links on the presentation here. Again, the archive path would be, archive, and then the user ID would be the PI name or PI group name, and that would be given to your PI at that point. Archive is shareable just like active storage is as well for groups. So transferring files. Now that you've got storage options available, you got paths in there, you got directories that are available to you. Transferring files back and forth. If you're a Windows user, there's a number of different methods that you can use to transfer data, or if you're any type of user, obviously. From Windows, though, specifically, you can utilize WinSCP. There's a link to download the application, as well as some instructions for setting it up. It looks like what you would see on the right there. Two different folder structures, okay, left and right. The right-hand side would basically be your ACI folders, your homework, Scratch, and or group if you have them. The left-hand side would be your local folders, a lab computer, your local machine, your laptop, whatever it may be, your home machine, whatever you're utilizing. And then it's just drag and drop from there. It's like any other Windows, right? I can drag the files that I want from the folder I want in my local directory, drop them into the folder I want them in ACI. We also do have some videos available out there on utilizing WinSCP. So if you have questions about that, watch the video, contact our IS Center. If you're utilizing Linux, Unix, Mac, okay, you can use SCP commands, okay, so you can SCP from those terminal sessions, secure copy. I'm not a big fan of it because I don't like to write it all out. I'm a little lazy. I like the drag and drop method better. But anyways, you can copy that. You just need to identify your source and your destination on there. There's not only the examples in this presentation, we have a reference sheet that's on our website under our support page that you can go out, has another example of this, and there's some other information out there you can take a look at. So if you've got a question about transferring files, we also have a short video out there on transferring files that you can go look at under our videos. Other options that are available, you can use rsync, okay? So for Linux users, Mac users, Unix users, you can use the rsync command. FileZilla, you can utilize SFTP. I've utilized FileZilla, works very well, no problems with it. I'm not transferring a lot of data, I'm just doing it for testing purposes mostly. If you have large amounts of data, like tens of terabytes of data, you should probably contact us and we'll try and figure out what the best method of getting that over is. The last one on the list there I see is Globus. We have actually had users transition over 0.5 petabyte using Globus, so it's worked out very well for us. Obviously, that wasn't all within one shot or at one time. They broke it up into some chunks, and it was over probably a period of 2-3 months. But it's doable, and if you don't need all the files right away, it's a great way. The notes I'll make on Globus are, it's a third-party application. You have to sign up for your own account currently, okay? I know Penn State's looking into some things, but right now today, you still have to sign up for your own Globus account if you want to utilize it. It's a web-based application, so you log in. It looks like a web page. It looks kind of like that WinSCP page, where you have a source and a destination, and you can choose what files you want from the source, where you want them to go on the destination. So had relatively good success. It's got some benefits. It's a store and forward capability, so if it gets shut off, if your access for internet gets shut off for some reason or glitches in the middle of a transition, it'll stop at that point, pick back up where it left off again. It gives you a notification when the transfer is complete, tells you the data rate, the amount of time it took when you kicked it off. So those are some of the benefits. And as you can see here, we have 3 different endpoints here within ACI to be able to utilize Globus. So when you log in there, it'll ask you, and we do have a tutorial on our a written document as well as the video here on our website that you can go out and take a look at that walks through kind of step-by-step utilizing Globus. So again, if you want to try it, I've had very good success with it. I'm really high on it right now. Not to say that might not change, but right now it's probably my favorite method. You can, if you have questions, ask our iAsk Center. Go look at the materials on our website. Okay, so for those of you who are not Linux users, Unix users, you can raise your hand, and I'm raising mine because I'm one of them. There are a number of basic commands that are available out there. We kind of put kind of the top 10, so to speak, or so in here. I don't run a lot of jobs on the system, but I've run most of these commands. You can take a look at those, obviously, if you want to change directory. So, if you're used to Windows and I click on my D drive and I go to a folder, now I want to go to my C drive, I got a separate one set up, I can go back and click on my C drive. That CD command just means change directory, so I change it from one to another, one folder to, or from my home directory to my work directory, from my work to my scratch, from my scratch to my group, whatever it may be. You can list the files that are out there, you can print your current working directory, you can create a directory, you can delete files, there's instructions for doing all that, you can look up commands. So there's lots of other information on Unix commands, basic Unix commands. There's Linux Unix for Dummies, there's all that good stuff out there, right? If you've never used it before, I highly encourage you to utilize some of those resources. I think maybe on our website we point you to some of those. If you ever have questions, contact our IS Center, and I'll tell you how to do that later on. Okay? So there are some things that are specific to ACI, okay, and specifically the batch systems, okay? If you have storage allocation, you can check your disk quota, okay? You can see how much storage space you have available, how much you've utilized. If you have a group, right, you can check your group's quota. It's a little bit different command. Allocations, you can check how much, so I'll talk a little bit about allocations and specific allocations later on. We're talking mostly here about the Open Queue, but if you're part of an allocation, you can check what's out there usage-wise, and you can display what's available in your allocation, and I'll talk a little bit about that later on as well. But the commands are there if you want to try those. Again, if you have problems, contact our IS Center. We support a centrally supported software stack. We have probably a couple hundred packages out there. Big Notes compilers, we have GCC, PGI, and Intel compilers available, okay, and then software for those. You can review the current software stack that we have available. There's a list on our website. Obviously, if you log into the batch system, once you get an account, you can look on the system itself and see what we've got there. Those are some examples, things like Python, MATLAB, R, that are available on the system. There's a whole host of them. I encourage you to go out and take a look. We do have a software policy So I encourage you to review the software policy. It does include the policy for requesting additional software. So if you look and you find that, hey, there's something you use and your whole college, your whole department uses that, and you think it would be good for us to have on there, you can request that. That goes through an internal process. It gets reviewed. If we agree, then we'll add it to our software stack. If we don't, you can still put it in a work or group directory and utilize it out of your work or group directory at that point, okay? We typically update our software stack twice a year. So twice a year is when we update it. Requests are coming in all the time, and we're constantly adding software packages to the system. But twice a year is what we've committed to updating the software stack itself. Okay, access and software. On ACI, it's a little bit different than it was on the legacy systems. So to use the software on here, you actually have to use the environment modules. Loading, it's a little bit different. So for anybody who was on the legacy systems, it's going to be a little bit different than what you saw before. If you haven't utilized high performance computing systems, good news, you're starting from scratch then, just like everybody else. But you can look on here, you can check for packages that are available out there. There's a module avail, module spider command. Module avail just kind of gives you everything, or you can look for a specific package. Module spider are what most people prefer nowadays, especially when looking for a specific package. So R, Python, things like that, if I wanted to look at them, I could go module spider MATLAB, for example, and that would bring me up the version of MATLAB, tell me the path name for MATLAB. You can load default versions, you can load specific packages, you can also load currently loaded packages, unload, switch packages. All those commands are there and are listed here. Again, try it out on the system. If you're having issues, contact our IS Center, they'll be happy to help you out. Submit a job. So now you got an account. You got your directories, you've downloaded some data to there. Now you want to actually run a job and submit a job on there, okay? Jobs are submitted to the open allocation, so you can do a Q sub. As you see, that's a Q sub dash capital A. That dash capital A is just for the allocation or location where the job's going to be submitted. In this case, the word open after that indicates that it's going to be submitted to the open queue, okay? Or the open allocation on ACI. That has some limitations I'll talk about later on. You can also use PBS scripts. There's an example of a script that's there. You'll need to specify some things. Obviously you need to specify the nodes, processors per node, the amount of wall time, okay? The -A open is where that job's going, okay? Processor memory, 2 gigabytes. Obviously if you're submitting a job and you're requesting the full memory on the node, 256 gigabytes, that job's going to sit longer in the queue before it actually kicks off, because it's got to wait until a full node becomes available. If you're requesting pieces of the memory, obviously that job would probably get submitted a little bit quicker. Module load package name, you would need to submit any packages or any software that you would need in there, okay? And then executable, or and then for where the directory for where your output would be stored then after that. There are examples of PBS scripts out there. Here's a quick one, obviously. If you have questions about scripts or scripting, contact our iAsk Center. Checking your jobs. So now you submitted a job, you got a job running, right? But you want to know what that's all about and how to see what's going on, right? There are multiple ways to see jobs that you have that are currently running or currently queued up, okay? There's a QStat command, okay? That shows all of your jobs, okay, that QStat. So that's just your jobs. Show queue shows the status of all the jobs on the system. And you can use some identifiers like show queue-u, right, which means that's just my user ID jobs. So I would put show queue-u and then my user ID ABC123 in there. That would show just one user's job or my specific jobs at that point. QStat's probably what you want to use. Show queue, I don't think you want to know everything that's going on with the scheduler and every job that's in the system. Typically you're more worried about your own jobs or jobs maybe within your group if you have an allocation. So checking your jobs, additional commands, you can monitor your jobs, okay? There's some commands here, they're QStat-u, right, with your user ID. That checks the status of all your jobs. You can check what nodes your jobs are running on. So are they running on standard memory nodes? I talked before, are their standard memory nodes Haswell or Ivy Bridge? Are they running on basic memory cores, right? Those type of things. So you can check which nodes your jobs are running on. You can get details about your current job. The commands are here to do that. I'm not going to go through each one of those. You can show the status of all your jobs, okay? Or if you've submitted a job and you find out you screwed up or you don't know what the heck you're doing, in my case, right, you can actually go in and delete your job, make sure it doesn't actually get submitted to the system. You can do any of those. Again, try the commands, contact the IAS Center if you have issues. These are just some examples of how things show up. Just shows you some of the differences between how QStat and ShowQ jobs show up. So when you run those commands, it just shows you the basics. QStat versus ShowQ versus ShowQ-U for your specific user ID, right? And how those would show up. Open Queue guidelines. I talked about submitting that job, that capital A to the open allocation. There are a number of Open Queue guidelines that you have to follow when submitting jobs to the Open Queue. No more than 20 cores per job. Okay, so you can't request a job for 100 cores. It has to be 20 cores or less. You have a maximum of 100 jobs submitted at a time. You can't, as a user, you can't submit, your user ID cannot have more than 100 job submissions at a time, okay? Jobs in the open allocation won't run unless resources are available. So jobs get queued up until resources become available, then they get slotted in to run at that point. Maximum wall time is 24 hours. There are no extensions. Please don't ask. I know we get a lot of people that ask. We used to do that on legacy systems. We are not allowing extensions on ACI at this point. If you need a wall time greater than 24 hours, then contact ACI, okay, and we can look at working with your PI to set up an allocation for you that would allow you to run jobs longer than 24 hours. Otherwise, you'd have to break your jobs up into if you want them to run just in the open queue, you have to break them up so that they run within that 24-hour window. Jobs in the open queue are eligible for preemption. So just because you kick the job off, if somebody with an allocation comes in and needs resources, there is the possibility that job can be preempted, just so you know that up front. Okay. As you can see, my contact information is on here, okay? Users or groups who need resources greater than what we described above, longer wall times, more than 20 cores, those type of things, you can contact me and we can talk about options for compute. So I've been talking a lot about the open allocation. Just real quick and briefly, I want to touch on the fact that we do have a great allocation. I talked the last slide about contacting me. So the GREAT model is a model where it's a guaranteed response time, and that's for anybody who needs additional resources or wants to utilize the compute cluster, right? If you want to get your own allocation, have your own allocation to submit jobs to, you can do that through that GREAT model. It's a guaranteed response time, so any job submitted to your allocation guaranteed to start within that 1 hour time frame, okay? It does allow you a burst capability. We talk a little bit about the burst capabilities here. There are some limitations to the burst capability. First off, burst jobs are not guaranteed that 1 hour start time. So if I have a 20 core allocation, I submit a job for 80 cores, I can actually burst up to that much because it's within that 4x limit. However, it's not guaranteed to start within that 1 hour time frame. It'll start when resources become available. I talked about your maximum is 4 times your allocation. So if you have an allocation, you can only burst up to 4x of whatever your allocation is. So if you have 100 cores, you could burst up to 400. If you have 20, you could burst up to 80, so forth and so forth. That's the maximum that you can do. Anything you submit outside of that, so if I have 100 cores and I submit a 500 core job, that job would be rejected by the scheduler because I don't have the ability to do that. I talked a little bit about the Open Queue as well, right? Anybody can get an account on the Open Queue as long as you have a Penn State ID, okay? You will need a PI as well. You need to specify a PI. So for students, you can specify your advisor if your PI is not willing to do it, but you will have to do that upon sign up. On the Open Queue, okay, it's open and it's available at any time. So even if you have an allocation and you've utilized all your resources, you can still compute in the open queue at that point. It just has those limitations that we talked about. You want more information on the access models? Those are on our website and the links on the presentation here. We've gone through a whole bunch of stuff: storage, compute, how to move files, how to access, how to submit jobs, all those good things. How do you get help? Because everybody needs help, right? So we have a couple different ways of doing that. Right now we have new training videos that we just put up. These are short videos, typically 10 minutes or less, typically 5 minutes or less mostly. But it talks about logging on, using PuTTY, submitting a job, managing software modules, transferring files, using FileZilla, using Globus, right? WinSCP. There's a couple others. We have about 10 or 15 of these out there right now. We're constantly creating more as we need, but these were kind of the heavy hitters. Getting accounts, signing up for two-factor authentication, those type of things. So I encourage you, if you have questions about anything, go check out the videos, see if there is a video available. If there is, I encourage you to watch that first. If there's not, then go ahead and ask our IAS Center. Folks there will be happy to help you out. We also do have additional training series, right? This presentation kind of goes through the basics of getting accounts, directory structures, files, things like that. There's a couple other presentations that we're doing throughout the year. Our training series, learning how to use the systems, okay? So if you're a new user to high performance computing, learning how to use it. There's a schedule out there that's available on our website. You can sign up for one of the sessions. There's a full schedule out there and you can RSVP, okay? To that. Additionally, we're going to be creating additional videos and additional training series for the spring semester, so check back on our website and those should be posted on there then. So support, general support. So we have what we call an IASK service center, okay? They can help you out. They can help you out with questions about accounts, questions about logging on, questions about using software, all the way up to we have folks who are more along the lines of computational scientists that can actually look at your code, look at your scripts, help you with some parallelization techniques, optimization, things like that. So we have a whole array of services that we can offer there and a vast array of topics that we cover there. You can contact our IAS Center, log onto the web and do that. Review any of the information. So we have a number of different documents as well as videos on our support page, so you can go out there and check those out. But I highly encourage you, if you're having problems, I talked about this many times before in the presentation, contact the IAS Center. They can get you help with most of the things that you need. Obviously, if you have questions about getting an allocation, getting a storage, or anything like that, you can contact me directly for that. Thank you very much for your time. We appreciate it. We're going to continue to try to do more of these, so any feedback you can give us on whether it was helpful, what other types of information you would want to see in here would be highly useful for us in developing new materials. Thank you so much for your time. Appreciate it and hope you have a great day.